Generic programming in C++. Maybe you heard about remember when I taught you about this in last semester's functional programming course. In generic programming, types are treated like variables and uses arguments for algorithms. So C++ supports generic programming with so-called templates, which are evaluated at compile time. Template arguments are written between angle brackets. So a very simple example of a template is you write template angle brackets class T, which might be any class. You could also write type name T. And then you write T mul add, which is a function that multiplies and adds some values, has three parameters, TA, TB, TC. And you suddenly have a template defined for all the types, a function defined which is generic for all the types that support plus and star, multiply. One can now use a template like this. You can define three integers, AI, BI, and CI, and you call mul add angle brackets int on AI, BI, and CI. You can do the same with three floats, but supplying float instead of int between the angle brackets. The compiler generates the code at compile time, which means that the generic algorithm costs space but not runtime. So it's just as fast as a non-generic function. C++ does not have a massive library, default library as Java has with thousands of objects, but it has the so-called SDL, the C standard library, which SDL is a big part of the C standard library, which is a library that heavily uses templates for containers and generic functions, and it's also called the standard template library. The SDL offers type-safe containers and algorithms and uses the concept of iterators. I cannot go into detail too much in here, but some parts are also explained and shown in the functional programming slides of last semester, so you might want to have a look back to that. An example of using the SDL is I have some class outInt which redefines the parenthesis operator with an int and just prints out the integer. And in the int function we create a vector of ints and a class that has this operator, which can be seen as a function object, but you have learned already last semester C++ 11 offers more sophisticated function objects. You can add elements to your vector you just created and then call for each from the beginning to the end of the vector, and on each element you call OI, the function object, which is essentially what map does in functional programming. A different example for using the SDL, objects are either completely constructed or not. There are no half-constructed objects, which means it is maybe difficult to achieve if exceptions may occur. So the auto pointer helps there. That means exceptions are always a problem if you have no garbage collection, because the exceptions might change the control flow of the program and manual deletion might not happen. So you can use auto pointer, which are garbage collections but don't allow the copying of objects. So whenever you create a new element using a new object using the new operator, which pushes it on the heap, but you wrap it inside an auto pointer or a shared pointer, which is also a different class that does more or less the same, then C++ will guarantee that this will automatically be deleted at some point. As a final part of the C++ introduction, I will give you a quick overview, a quick idea of how compiling in C++ code works and what a make system is. You will only use a make system if you choose to program C++ in Linux, but for the sake of completeness I will also mention it here. Most of you will be using Visual Studio since it is installed on the lab machines at FH and takes a lot of work away from you. The most important part here is this. How do you get from your source files, from your H and CBP files to an executable, to a .exe or a binary executable file? First of all, the C++ compiler compiles C++, CBP and header files together into so-called object files. There's, let's say, one object file per pair of header and CBP file, and then another part of the compiler, the so-called linker, combines these object files into one executable or library. That means, first of all, one thing: your compilation may fail at two different points. First, it may fail to compile because you have syntax errors or similar, and then there will be no object file generated. And you can also fail during the linking stage, when the object files have all been generated, but linking fails for some reason. Here's an explanation what you can do if that happens to you. So your linker may complain about symbols it cannot find. That means it does not know about some functions, essentially, or members. Possible reasons for that are: you declare a symbol but you never define it, i.e. a function only appears in the header but is not defined in the CBP file. You include a header file from a library but you do not link against it, which essentially is the same error, but you take stuff from a library instead of writing it yourself. Or your object may have been compiled with a different C++ compiler and you suffer from name mangling issues. That's a minor issue. You will compile all your objects with the same C++ compiler anyways. Or your object is out of date and you have forgotten to recompile it. That means, whenever you change one source file, you have to recompile the associated object. And for that you have so-called make systems. Why do you need make systems? There are projects that have hundreds of source and header files, and you create a handful of binary out of all these sources. You have to link the right object files into the right binaries, and you need to avoid linking old against new object files. And you could always recompile the whole project if you have time, because C++ compiling is kind of slow, and for a big project like the ones that I do at my company, it happens that some projects may even take more than an hour to compile if you compile the whole project. So if you just do one change, that's not very efficient. Make systems offer usually the following features. They know about dependencies of each source file, so they can decide whether a target has to be rebuilt because of one of its dependencies has been altered since the last rebuild. You need to know how to rebuild a target from its dependencies, and it should be flexible to support unknown targets from and rebuild rules. A quite simple but powerful system is GNU Make, and it's available on many platforms, in particular Linux platforms. Essentially, it uses a file called makefile to learn about dependencies and rules to generate your projects. And this syntax is simple. You have some target, which may be an object file or your binary. You say what it depends on, and you can supply some compiler commands on what to do. So there's a really simple makefile example, how you would write a Linux makefile. You have a binary called bin, which depends on two object files, o1.0 and o2.0. And you compile this by gcc -o, which means you want to link stuff together from o1 and o2 into bin. or minus O actually means that should be your output. After that, you can define how to get O1.O. You define it by, you say that it depends on C1.H and C1.C, and you call it, and you create O1.O by GCC minus O, which means you output O1.O by compiling C1.C, and you do the same thing for O2.O. Also, GNU-Make also supports a lot of advanced features. It knows about popular file suffixes and knows the rules needed to rebuild such targets. You can check out this page to find more information on that if you're interested. Then again, this is optional because most of you will be using Visual Studio, I assume. This is all for the introduction to C++. You should now have a certain idea about C++ and be able to create your own simple C++ programs and understand most of all of the errors that a compiler may throw at you and how to solve them. If not, post your questions on the forums. Feel free to discuss it with other students. If you know the answers to the problems of your colleagues, feel free to answer. I will also answer questions on the forums. Yeah, and I hope you will enjoy using C++.